How do magnetic fields move particles in space? Well, that's because charged particles are forced to follow the path that a magnetic field line makes. If you are a charged particle, then you are forced to spiral around a magnetic field line. If you are positively charged, then you go one direction, and if you're negatively charged, then you go the other direction. They also slide along the field lines lengthwise, with the line itself steering the center of that spiral. We space physicists call this the guiding center. Earth's magnetic field lines run from south to north, and as particles travel along those lines, they reach each of the geomagnetic poles. When they reach those poles, they actually bounce and travel back in the other direction, and they do this repeatedly. It's actually why the northern lights and the southern lights are often mirror images of each other. Another way that particles move is that as they travel along these lines and run into each other, their spirals get larger because of the added energy that they collect. When they collect enough energy, their spirals grow large enough and they actually can be captured by a neighboring field line. And when this happens, we call it magnetic drifting. So as you can see, particle motion may seem pretty dynamic and chaotic, but it actually follows a pretty established pattern in the presence of magnetic fields. This spiraling, bouncing, and drifting motion of these particles along the field lines is what turns near-Earth space into a particle machine, complete with trapped radiation belts, twin auroras, and even hazards for spacecraft and astronauts. So the next time that you see an aurora or you think about the radiation belts, just remember that they're all following along this big particle dance that's tuned by invisible magnetic fields. Which of these particle motions would you like me to explore further next? Bouncing, drifting, or spiraling? Let me know in the comments below. Cheers.